can do this. Hey, good afternoon, everybody. We'll get going in just a second here. Just trying to get situated in the classroom. All right. Awesome. Yeah, that ought to work. I'm just going to see if I can get this on this screen real quick. All right, cool. So I can have chat in there. Maybe. Looks good enough. All right. So thanks for coming to the lab this morning, or I guess it was still this afternoon, right? Does that count? It was noon. It's not afternoon, but it's not morning. English is hard. Still morning? Okay, that's fair, because it's not quite after. Yeah. CIS 2001. Oh no, I'm sorry.
Thank you.
Okay, yeah, this is 1165. So they just changed rooms around like yesterday. So if you go look online, that should have the correct room number.
Okay, thank you.
Yep, no problem. Sorry that they don't assign rooms early enough, and then things change. All right. So we did our quick lab intro for anyone who hadn't done GitHub yet. Just to get us started up and running. We'll spend more time this week, today and Thursday, looking at some other workflows in Git. The Classroom tool is fantastic because it will create repositories for you, but in the real world we don't have a Classroom link that sets up repositories. So I do want to take you through that. We'll practice that in our next lab, where you can make your own repository and do all sorts of fun stuff with it. But it'll just make life easier for submitting things. And then we don't have to deal with attachments in Canvas because I hate attachments. We should use a tool that's made for code collaboration to store our code in. That just makes life easy for us. So real quick, it's only 3 pages, thankfully, for the syllabus here, because most of the general stuff is over in this course policies section. Hopefully you had a chance to look at this. So these should be general to all courses, course policies for nearly everything. So here's us, 4 credits, although we meet. So it's an hour 15, which counts as like an hour and a half because of the way things count. I don't understand how any of this works. So essentially 3 credits worth of lecture time and 2 credits worth of lab time, like almost 2 hours there, almost 3 hours here, for a total of 4 credits. I don't know how the math works, but this is what it is. That's our class here. So we're going to meet either in person, remote on Twitch, or you can watch the videos on YouTube if you like. Feel free to change it up, whatever works best for you that given week. Please don't come if you're sick, right? That being said. So everyone's got the Responsiblue app, our cool U of M branded app. So you check in, do all your good stuff there, and it shouldn't be bad. We did get a note from our dean on Monday saying policy enforcement and things were a little lax, and some people were upset about it. So I don't know what happened. It's Tuesday, and I haven't had any issues. So maybe you guys are just better than the Monday crowd. This is my cell number. I don't have an official office with like a desk phone, and even if I did, I wouldn't use it. So feel free to use my cell phone number. Call me anytime. Text me anytime between like 8 and midnight or so. I'm up late all the time, usually even later than that, but that's a decent cutoff point. I've got 6 kids, another job, and I teach part-time, that sort of thing. So if I don't answer, just let me know what time is a good time to call back. If it's okay to call you back at 11 p.m., I probably will, because it's when it's quiet at my house. If you want me to call back at 7 in the morning, usually I get my daughter off to school at 6:30, and then I try and take a nap, actually. But sometimes that doesn't happen. So I could call you early in the morning, too, if you want. Other times hit or miss. But I called someone back at 11 p.m. because I had just finished up all my stuff. I got their voicemail, and they wanted to talk because it was an urgent thing. And they were all mad at me because they had to be at work at 6 in the morning. And I said, well, don't tell me it's urgent. I have to call you back right away if I can't call you back right away. So that was fun. I don't have any set office hours. I was just going to go by appointment. Virtual is really easy to do screen sharing tools, but I'm on campus Tuesday between our lab and lecture time, and we do have some office space over in the CIS building in 239. It's the east end of the building. I was wrong from this morning. The east end of the building, up on the 2nd floor. It's not labeled well at all. But there's a room number at least, so you could probably find it from there, or just send me a message and I can come out there and holler at you, and we'll find it. Other than that, virtual by appointment is easy. I might be here earlier on Thursdays. We'll have to see. It kind of depends on what else is going on. Generally, my plan is to meet on Discord then, unless you want to meet in person. So maybe I'll update that alternate room number in a minute. Specific goals and things. So these are program learning goals. So these are pieces of the undergraduate data science program that this course will touch on. Out of all of the program goals, that sort of thing. So analyzing complex computing problems, applying principles of computing and other relevant disciplines to identify solutions. It sounds like a bunch of gibberish, but can you solve problems? And we're going to learn some tools to solve problems. So like it fits in this category, that sort of thing. Most of these are boring. You can read them later. But these specific course objectives, these are ones that we will do throughout the semester, different assignments mapped to this sort of fun stuff. We have to do assessment of these objectives for our accreditation process, which is not fun, but it's necessary that people actually do this accreditation stuff. So it's all good to do. So test cases and test plans, medium-sized programs, stub procedures, top-down testing, bottom-up testing is good. Trade-offs for data design implementation. So the second half of the semester, we're going to get into data structures. So we're going to wrap up our computer science fundamentals that we started in 1501. Real basic, this is how programs work. We get into some more advanced object-oriented principles this semester and then wrap up that, and then we start some data structures. For the undergrad program, usually continue on into algorithms analysis and data structures in 350. So it should be the same textbook for you. They write it in C++, they write it in Java, and they write it in Python. Because we get transfer students who only know Java, we get data science students who only know Python, and we teach C++ to our computer science undergrads because we're mean. I do C++, I just don't like it. It's not a good starting language. So much happier to teach Python. Modifiable software, like when we design software in a certain way, we follow good object-oriented principles, it should be easily modifiable. It's awesome. Linked lists, stacks, and queues are the data structures we're going to focus on mostly. We get into a couple other ones that are more, we're going to touch on the topics because we've got a little bit of time while working on that final project. I want to introduce the topics. You'll take a real deep dive in that data structures algorithms analysis class later on into how these things work, but I want to kind of tee it up for you. So you've seen it before. Look at some basic sorting. This is not too bad. There's built-in Python sorting, which is better than what we can do because really smart people wrote it and really smart people looked at it and said it's good. But we're going to look at some basic sorts that we can accomplish ourselves that are easy enough to write. Existing class libraries. There's so many built-in libraries in Python. It is fantastic. That's why it's one of the best data science tools because people just keep writing libraries for it, and we can do all sorts of cool things. We're unfortunately not going to do anything like super cool and fancy data science-wise. We're going to look at doing some modeling of a particular problem and run some simulations to generate our results. We're not going to do anything strictly mathematical, but I think that's a fun way to kind of look at some of these things. Our object-oriented design to create our own libraries of classes that solve real-world problems. That's always fun. Data abstraction, data hiding, functions, and inheritance. This is the core of object-oriented principles. This idea that we're going to hide away the details and you just deal with my public interface. You get to deal with all of the methods and functions that I write that we've marked as public. You get to access. You don't need to know the details and what I actually store behind the scenes. So we're going to hide away that data, just give you that public abstract interface to work with, or your API, your application programming interface. We define those functions, and then we'll make use of inheritance as well. So this is all about making a special version of a class. So you don't have to reinvent the wheel, don't have to do a lot of work. We'll work with the Unix file system and Unix shell commands next week in lab. I'll double check to make sure you should be able to do it remotely, but you might need to get another tool for it. It's a free tool, so it's no big deal. But we've got everything here on campus, easy enough to do. And then write a medium-sized program as part of a team. So the last final project ideally is a two-person thing. I mean, two is sort of a team still. It's not a large team at all, but anything bigger, it just ends up not enough work for people to do, or it's just too large of a project. And for most people, this is only their second programming course, so we don't tackle anything crazy. So, oh, my power shut off again. This is not going to go well if this keeps shutting off. There it goes. Just can't drop it down. Maybe. Oh, thanks so much for following along. So those are the course objectives. So throughout, we'll tackle those in our projects and our things. Just another note, Discord and Twitch are public platforms. Use whatever username or handle you want. Does not need to include your name if you're joining us remotely on Twitch. I've actually gotten some feedback that some students were more comfortable being able to ask questions where I don't know their real name, which, sure, I'm not going to bite your head off if you do ask me questions in life, real life, but if that makes you more comfortable to ask questions, go for it. The Discord link again, so this is my Discord server, so all the classes I teach share this server. There's a channel for each class out here in my server. So any of my classes at OCC, classes at U of M here, we've got specific course channels. If you have pictures of your pets, I love pictures of pets. I've got 3 cats at home. Some people have some really cute dogs, and I think these are hamsters or gerbils. I don't know. Feel free to post there. Any safe for work memes here, nothing inappropriate, please. It's not officially a university thing, but still keep it safe for work, please. Gaming, if you like to game, feel free to chat in here. I play Fortnite with my kids. They play with their cousins a lot. That's actually been really fun in the pandemic to kind of get together and game like that. Other just interesting tech stuff, and then career info. My vision is that eventually we've got a network of people who just never leave the server. And then once you go out into the real world and you find places that are good to work for, or that have internships, or that you shouldn't go work for because they were awful, we can kind of build this out. And if you can have this network of people with me being the common thread, that'd be fantastic. So I just got this from a student last semester. They're hiring intro-level software developer. Like they said, 2 to 3 years experience. Literally, college classes count towards this. You don't need any professional experience, which I almost never see in posts. So I was thrilled that they would say, sure, we'll take you fresh out of college. Even before you even got your degree, we'll take you fresh out of college. As long as you've done some coding, at least you might have a shot at an interview. So I don't know who's going to end up in the spot, but like that sort of thing is just super cool to see. So if you got stuff like that to share, that's awesome. I've got another former student who's hopefully be posting an internship soon. I keep hounding him about it. He got it approved by his company, but they haven't funded it yet. So he just has to finish his paperwork to get the funding done so he can get an intern. But that's sort of fun stuff. Twitch, if you like the live stream lectures, don't want to come in person, that's cool. Or if you don't want to use it at all, that's fine. I do eventually get money from Twitch. I've gotten a check one time for $100, and don't think I'm double dipping. Any of that will go directly to the Student Scholarship Fund at the College of Engineering and Computer Science here. So I've got a record of it on my Twitch page. In case you're curious, I'm happy to show you receipts. I'm not making money off Twitch doing this. It's just a fun platform, and I hate Zoom. So that's all. This one's the textbook. A couple of people asked me. Sorry, I kind of hit it in the middle here. You can find it in the bookstore. You can find it online. You can really find it online if you search enough and find some sources. So it shouldn't cost you an arm and a leg. It's a decent book. Goodrich did a decent job with it. I hope he gets his royalties there. Always happy to see authors make their money. But and Wiley's not the worst publisher. They're no Pearson for sure. Pearson, I hope, is just, they're awful. So they just gouge people left and right. But it's a decent book. For some of the data structure stuff, we basically followed the text because it's really done already. We're sort of copying it out. I'll change a couple things here and there, make some comments. I don't really like everything he does as he goes through some of his data structures. I try and simplify things if I can, but all the really technical advanced stuff is in there for the next class when we get it later on in there. So definitely would go get it. We'll have quizzes every chapter. Anything I say is fair game. Anything from the text is fair game. It's open book, open notes for quizzes, so you don't need to memorize anything. I've never had an employer tell me that I need to solve a problem for them, but I'm not allowed to look something up online, because that'd be stupid. So the same goes with you guys. Just know where to go find your information. So it's just stuff I say and just stuff out of the textbook. You shouldn't really need to Google anything and go down a bunch of rabbit holes. Like if you know, hey, this section in the textbook is about this topic, this section is about this topic, this section is about this topic, and you've done a little bit more than skimming, right? There's like levels of reading, right? You can read every single word. You probably don't need to even go that far, but you need to do more than just read the bold words and say, oh, here's a bold word, here's a bold word. Here's like, you have to do more than that. So somewhere in between, a happy medium, and then know where to go find it if you see a question about it or want more information about it, that sort of thing. But it's a good reference. That's our main reference for the course, the only textbook here. You should all have your GitHub accounts already now from lab. That one is public as well. I should have added that to the note up here. It's not associated with you at all, unless you add in your email address or anything like that. So it shouldn't be tracked down to you, but like your username will show up. So my GitHub account is github.com/Eric Janeski, because my username is Eric Janeski. Makes life easy. I'm the only Eric Janeski in the world. All of my kids have hyphenated last names, so there won't even be an Eric Janeski Jr., which is actually easier, because then it would be confusing when you try and Google me. So just makes life easy. So I use public GitHub repositories for all the code examples in class. So anything that I show in class, any of the code that we do, will go out here into one of these repositories. So we had 1501 from fall last semester is out here, and you can go through and you can see all the different things that we did. I go over labs. Usually the Tuesday after the lab, so we used to do labs on Monday, so that's a little funny. So generally I'll go over the solutions after lab. I put us like to the week after Wednesday or Thursday. I don't know if that'll work. We'll see. But happy to go over labs, spend some time talking about them. Ideally, you're done with labs before you walk out the door of lab day. I don't make them due until the next week at 11:59 p.m. because things come up, and sometimes you just need some extra time. What happened last semester was not great in that people would show up for lab, and everybody would work on last week's lab. That wasn't the idea, and it was fine. Like it's not a bad thing, but then you're a little bit behind. So the way that the schedule flows is labs should be about the stuff we've talked about the previous week. So the lab Tuesday morning is about previous Tuesday, Thursday lecture. So I talk about it Tuesday, Thursday. We come around, you have your practice time lab that Tuesday morning, and then we pick up new stuff. So if you're 2 weeks behind, it just gets you a little bit off cycle on the content. And then I'm talking about new stuff you haven't had a chance to practice yet, and it can get a little confusing. So do your best to keep up, but we've got the wiggle time if you need it. Not too concerned there. I'm going to use Pycharm for the class. I think it's a great IDE for the things we need it to do. There are other Python IDEs. You're welcome to use anything you want, but I'm going to show you Pycharm, and it's got some cool tools built into it. They all should be able to do their unit testing that we need to do later on. I'm just not as familiar with all the different IDEs, and that's fine. There's a bunch of them out there. So if you have one you've used and learned on, that's fine. No need to switch necessarily. So grading for the course, this is weighted categories. So just because a lab is worth 10 points and a project is worth 10 points does not mean they'll have the same final impact on your score. So out of all of the lab points together, your score on those labs will be 10% of your overall final score. So if you get 90% on your labs, you'll get 9 out of those 10 points of your final grade. 9 out of 10% out of that final 100% for your grade. Generally that makes sense for people, but it can be a little funny. It's set up really nice in Canvas. The what if tool is usually pretty good. The only thing I don't have is I don't put grades in ahead of time, so you don't see all of the next assignments. If you want to see those, I can put them all in for you ahead of time. But one time I did it and people were like, hey, I just got like 30 emails and you put a bunch of stuff in, and it freaked them out. And that seemed a little silly because Canvas is nice about emailing, but also emails you everything I do. So generally, like as we have the lab, I put it in. As we have the project, I put it in. If you, I don't know, I'm open to either. That's fine. We'll do quizzes, open book, open note. Open internet quizzes, they are not open neighbor. These are your individual effort. Again, you shouldn't have to go look things up online. Use the textbook, go back to lecture notes, watch the recordings if you really want to, although that would probably not be a very good use of your time if you have to watch 3 hours or two and a half hours worth of recordings just to answer a couple questions. But that's out there. The individual projects we'll do throughout the semester. We've got 4 individual projects to tackle. We're going to try and do one every 2 weeks. Is the goal. So for every major project, you'll have at least, or 2 weeks, I should say, maybe not at least, to get it done. Do start early on them, please. Don't leave it till the last day and then panic and ask me questions. Right? If you start early on it, it's a lot easier to get it done. If you're not sure about things, you can ask me. That's all well and good. For labs, you're welcome to essentially work together. And by work together, that does not mean you write it and I copy paste it. Right? But by working together, hey, can we talk about this? Can we figure out, okay, this is what I need to do? Today's was not a good example of that. But when we have to actually do small little tasks and you have to do something, you're welcome to chat about it and kind of puzzle it out together. Don't have one person solve it and both people write it, though. right? Like the working together, it should be collaborative, not copying. And I'm fine with that. Quizzes, though, individual projects, again, individual work. If you're not sure about something on the projects, it's my particular style on projects that they're generally a little bit vague. You say it has to do this, and it's left rather open-ended. So if you're not sure exactly what I'm looking for, ask me. Ask in class, ask in the Discord. Just general questions are great. If it's, hey, my code is doing this thing, don't paste your code into the public chat. Send it to me as a message on Discord or email it to me. Commit it to GitHub and send me the link. Right? I'm happy to look at code that way. But general questions like, hey, I'm not really sure what exactly do you mean when I need these sorts of inputs or these outputs or X, Y, and Z. Ask them. Right? I'm happy to answer those. And again, if it's not clear to you, it's probably not clear to someone else. Right? So do everyone a favor and be the one to stick your neck out and ask the question, because I'll be honest, they're vague on purpose, right? To make you spend a little bit of time and do that critical thinking and kind of puzzle through, well, what exactly does that mean? What exactly do I have to do? It's not, here's a sheet and you just have to fill in some blanks, right? It's going to take more work than that to solve these, and that's the goal. So the final project, again, done in pairs if possible. I know we're kind of in the midst of a global pandemic, but we've got good remote tools for this sort of thing. So if we end up with an odd number, we can do one group of three, maybe, or maybe that one person could do one, but like the goal is it's supposed to be teamwork. So I'd like 2s and 3s, but limited 3s if possible. For the quizzes, they're nice and short. No coding questions, almost no coding questions. Very limited. If I wanted you to write some code, it would be just a 2-3 liner at most. If you're going to have to write any code. Generally, I like these kind of questions that are true-false questions, but if they're false, you have to correct the statement to make it true. I think that's a more fun way of writing a true-false question, because I think multiple-choice questions are trash. I don't think that really tests much of anything, like recognition, I guess. Like, oh, I recognize that sentence. Like, you're not actually answering a question. I don't know. So generally, the questions are like that. They're not too bad, right? Anyone who had last semester, the quiz questions, yeah, they're okay? Okay, not awful, right? If they're awful, you can tell me it's okay. Yeah, so and you'll get a feel for what they feel or what they look like after the first couple. And then we have one exam, just a midterm. It's worth 20%. It's higher than I'd like it to be, but we have all week to work on it. It's open book, open notes, open internet, so there's no time bound on it aside from the due date. So like it'll open at the beginning of the week, it'll be due by the next week, so that you've got it done and out of the way before spring break. Or yeah, spring. It's not even spring. It's March in Michigan. It's still winter, but we call it spring break, I guess. It's a hopeful spring. So it's worth a decent amount of points here, but you've got lots of time to work on it. It'll be half quiz questions. I'll literally take the quiz questions and put them into a question bank, and you get a couple of them, and then half coding questions. Smaller than projects, larger than general quiz questions, like, hey, write a function that does this, or write a class that does this, or do something X, Y, and Z. I'll give you last year's midterm for review, because I have to rewrite them thanks to websites like Chegg and CourseHero.com, which you all have agreed not to use. Thank you very much. But I have to rewrite it every time anyway. So if the question was about classes, you'll get a new question about classes, just a different words, that sort of thing. So there shouldn't be any surprises there. I'm not a fan of tests, not a fan of time-bound things at all. I mean, in the industry, there are things that have to be done by a certain amount of time, but it's rare to be like, sit down, spend 2 hours, do this thing, or else. Like, and it's a huge portion of this. Like, we know it doesn't work like that, so I'll try and avoid that the best I can. And then there is no final exam. Our final project takes the place of an exam. So worth a large chunk here for a single assignment, but we've got essentially the last month to work on. If we time things right, we'll start the first project here, start the second project here, and then we'll start the third project here, the fourth project here, and then by the first week in April, we'll start the final project. That's the goal for that. I didn't put in official dates here because every now and then we need an extra weekend. Just depends on how things go. But ideally, there's a project every 2 weeks starting next week. So we get 4 projects out of the way, and then we have our final project. We have all of April to work on. I haven't seen the final exam date yet, but this was last week, I think, when I looked. They hadn't published it. I don't remember if they have yet. The projects are going to be individual projects. The final project is the group project, done in pairs, possibly a trio. And then the last week of class, the lecture time, I have no plans to say anything. Just set aside purely for you folks to get together. Before the pandemic, it was, hey, sit next to your partner and work together. Obviously we might not necessarily want to sit next to each other, but we'll have the time set aside. We can use some remote tool to collaborate or whatever you need. I think everyone has a Zoom license. You can hop on and screen share there. You can make use of Discord. It does decent screen sharing, that sort of thing. And then instead of the final exam on that 3-hour block, we just have all the teams present their final project. And they'll show us the results of their project and what they did. So everyone takes turns. I grade it on the spot because you've turned in your code. Hey, Hector, thanks so much for sharing some bits and donating to the Student Scholarship Fund over at the University of Michigan Dearborn. That's so cool. Hector has been awesome supporting the scholarship fund here. That's so cool. And crazy, like we can just be out on the internet and people do this kind of thing. So, I don't know. I think it's cool. If YouTube ever sends me money, I'll also put it to the scholarship fund, but I have to get 1,000 subscribers on YouTube before they'll even consider sending you money. And at like 100 people a semester, it doesn't add up that fast. One day I'll get to 1,000 people, but yeah, so that's the tentative plan. Again, so we'll have topics the week, Tuesday, Thursday. Next Tuesday morning is lab. Wrap up that top of the extra practice time. In addition to, after you're done with your lab, you're welcome to stick around and work on the project. Like every 2 weeks, we're going to have a project. So we'll have something to work on. So except for midterm week and spring recess, there's always something to be working on unless you get ahead. If you're done, great. But you can also use that time to work on the project. I can be around, answer questions about that, and we can go from there. So when we get to trees, we take a little bit of a lighter touch on trees, specifically search trees. We do a little bit lighter on because that's a more of an advanced topic. So we wrap up priority queues and maps are kind of the last deep dives we take into full-fledged data structures. We'll look at search trees, but we're not going to write all the implementations. There's some really cool stuff on how to do really quick search trees that honestly smarter people than me do, and that's fine. I'll leave it to the smart people. I just want to use these things to write software. We'll talk about sorting and selection. We're not going to look at all of them in that chapter. We're going to, again, look at the easy ones, the ones that'll make sense to us that we could actually code ourselves, have some fun there. So we'll go deep on object-oriented programming principles, deep into recursion. We've done array-based sequences. That's the Python list. If you're doing this in C++, they have this thing called a vector that they can make use of, and you write your own. So we're going to essentially write our own list in Python, which is kind of silly because Python has a list. It's going to feel kind of dumb, but we're going to look at performance-wise, why does it matter if I use an array-based sequence versus a linked list? And we'll kind of do that trade-off, that analysis. Well, when is this going to perform better? When is this going to perform worse? So that when you're solving problems in the real world, in your toolkit, you're like, okay, well, which one is better for what thing, right? One's a round peg, one's a square peg, one's a triangle peg, which is going to fit in the right hole to solve this problem better, that sort of thing. Stacks, queues, and this is pronounced decks, I found out, which is the weirdest word. We'll spend a lot of time on these as well. These are some elementary, some basic data structures that are a lot of fun. Much more specialty use. But it's good practice to look at some of these things, and you can solve problems with them if they fit. Things have to look a very certain way, and of course the project that you have will look a very certain way that can be solved with stacks and queues, go figure, that sort of thing. Yeah, so I think that's about all we've got. So we skip over to the primer chapter. So if you're new to Python, definitely take a look at chapter 1. We're just going to kind of skip over it. Don't need to sweat it too much here. But we'll jump in at 2, spend a lot of time with object-oriented programming principles, and we skip over 3 because we don't need the entire chapter. That's all about the algorithm analysis. We'll talk about some of those topics when we actually get to the rest of them, but we don't actually pull it out as its own chapter ever. There's all sorts of cool Greek words you use or Greek letters you use to analyze things. We focus on basically one of them because most of the time that's the only one that matters to us practically. Later on you can learn the other stuff in the other classes, and all sorts of other upper bounds and lower bounds and all that fun stuff. But for our practical purposes, we're going to look at just average case, average time. Yeah, it should be pretty good. So no lab on linked lists. because we're setting aside that time for the midterm. So the lab for linked lists will actually be on 3/8, which is like almost a month later, or 3 weeks later, I guess. So the linked list lab will pick it up eventually on 3/8, because we're not going to do a lab that midterm week. So you've got all that time. If you want to use the lab computers, great. If you want to use your laptops, great. You don't have to come to campus at all. We got that whole week to focus on the midterm, because I want you to have the time for it and not have to feel like you have to cram this in outside of that. Should go pretty well. They used to make me give the midterm like during lab time. We had an hour 45 to do an exam, and that was just awful. Timed exams are no fun. So thankfully with the pandemic, they're like, oh, let's not do that. And I said, okay. And now that we're back in person, I still don't do that. It just works out. Yeah, so we should be good. The lab time as well, there's no, so we might have an ethics lab. We can do a little bit of ethics lab. It'll be real quick on the 19th, but essentially we can have lab time for final project work time too. We can see if they've set the dates yet. That's good. Oh, and this is last semester's, right? Let's see. Oh, they do have winter. Okay, so we'll find out when ours is, and I can update that. So the first lecture period of the week. So our lecture period is Tuesday 3:30, not Tuesday noon, because that's our lab time. I've been confused by this thing before. They had to. Oh, that didn't zoom right. What's going on here? Let me just download it. I'm sorry. No, I don't want to sign in. Here we go. Let's see. That's the wrong folder. Nope. All right. We can actually plug in our time here. So let's see. So if our time of class is, we're 3:30, but I think that falls under K, right? Does that sound right? Yeah, class starting at 3:30, we use K. Oh, or Tuesday though. Tuesday 3:30, so we are O. Exam code O. Right? Am I reading that okay? Tuesday 3:30, we're O. So ours is going to be Thursday, no, O, Thursday the 28th, 3 to 6 p.m. Does that sound right? Okay, let's plug that in. Thursday the 28th. That shouldn't conflict with anything, so do let me know. So this is Thursday, 4/28, 3 to 6 p.m. here. And if we've got people doing the virtual option, we'll have a Zoom session set up for it, just like we're going to do for lab. I don't need anyone to come in person, because we can just all join remotely. If you'd like to come in person, sure, let me know. We can reserve the room and come in. I don't plan to, though, unless you'd like to, if that sounds okay. We can just all join on Zoom. That way everyone can do the screen share. Otherwise, you've got to come up here and screen share, or screen share from where you're sitting, and it's just silly, if that's all right with you folks. So we'll present our final projects. Presentations on 4/28. Okay, that's good. So we get a whole week after their last meeting time. That's good. Be a little bit later in the schedule there. I mean, ideally you're done, so you can worry about your other final exams. But I depending on how things go, you can put it off, or you can get it done and out of the way. So make sure your partner is cool with that, though. All right, so we'll have time. Again, because search trees, we're going, or sorting and selection, we're going a little lighter on. Ethics is not going to take the whole time. It'll just probably be one session, probably the Tuesday. So we'll have a little more time that Thursday as well to do some final project time. So we've got some time set aside to work on it in class where we're already here, or virtual, that sort of thing. But again, with any college class, the general expectation is that you're spending 2 hours outside of class for every hour in class. So for a 4-credit class, that's about 8 hours worth of work outside of class, whether or not it's reading and studying, whether or not it's doing the quizzes, doing the projects, doing the homework, the labs, that sort of thing. Ideally, the labs don't take you additional time, because really we're meeting for like 5 hours, but because that's like the hands-on time, it shouldn't necessarily count as much. So do plan on it being a decent amount of work. It's not stuff we can always get done super fast, but ideally we've got time for everything. We've got the 2 weeks for every project. So if you plan accordingly, it goes pretty well. All right, and then specific course policies. I have a specific academic integrity policy for the course that is different, I suppose, than the general university-wide policy. So you're welcome to help each other talk about things, right? My general rule of thumb for that is if you have a discussion, perfectly fine. If you start taking notes, you've probably gone too far, right? We've gone out of the general discussion into more specifics if you're taking notes. So as long as you're not taking notes, sure, let's chat about whatever. Perfectly fine. I know that's kind of silly, like if we're chatting on Discord, so don't worry too much about that. Again, I'll point out, if this is getting too specific, please take it offline. So, secondly, for the midterm, it'll be half quiz questions and a half bigger coding questions. So I'll give you last year's as well. Yeah. As long as it's the same, reinforce ideas from previous quizzes. Few questions involve actually creating a program to see a result. Yep. So that'll be what the midterm. And I'll give you last semester when we get a little closer. So sharing your code with somebody is plagiarism, right? Whether or not they copied off of you or you gave it to them for them to copy, right? Both people are in violation of the policy at that point. So when somebody says, "Hey, can I see your code?" Tell them to go get lost, right? You're welcome to talk about it and say, "Okay, this is an approach I took," or "Here's an idea I was using," but don't give them your code, right? The GitHub repositories are private, makes life easy. Just put all the code there, and we're all happy. If people turn in programs that are too similar, I'll ask you to explain what happened. It's generally obvious if you copied off of someone else. Generally. I'm not going to say I've caught everybody, but usually when I go through, and that's why I don't grade things till everything's in usually, for the projects at least. I wait till they're all in, so I look at them all at once, like in one sitting, just take a couple hours and sit through everything, because it'll stand out in my head. If I just grade 1 or 2 here and there, I'm not going to miss that sort of thing. So if you're guilty of an academic integrity violation, the dean's office gets notified, and the academic code of conduct committee. It's this whole process. It is lengthy. I have to do lots of paperwork. It upsets me to do all this paperwork to fail people. I rant and rave about it all the time, and I think in the 10 years I've been teaching, I have yet to have a single semester where I haven't failed somebody for cheating, which is really unfortunate. I don't like failing people. But that's what it is. So if you're involved in an academic integrity violation, you immediately fail the class. There are no other consequences. This is the course policy. This is what's different than other courses. So there are a range of things that could happen, sanctions that could happen. The one chosen for my course is failure. Cheaters should not get degrees. It's in your best interest to make sure cheaters don't get degrees, because if they go and get a job and they don't know what they're doing because they've cheated their way through school, no one from that organization is going to want to hire anyone else with the same degree as them from the same school, because they're going to think we sucked at what we did, right? It devalues the degree for everybody. So please don't cheat. If you're not sure, just ask me, right? My goal when I write these projects is that you can't go Google them, right? They're like nonsense sort of puzzles and projects and things. So you shouldn't be able to go Google it. I had somebody, which I used to think was obvious, but now I have this other line in here that you can't go post it on Chegg and then say, "Oh, look, there's an answer on Chegg," because they posted it and paid for that expert answer service for someone to give them an answer, which was ridiculous. So any use of Chegg or similar sites like Course Hero and whatever are considered violations of the academic integrity policy. Under no circumstances may you go there. Right? It's not like a math class where you're going to get the answers to the even-numbered questions. No, it's just trash. Stay off of their site, please. It'll make life better for everybody. Okay? Sorry, I have to spend way too much time searching on Chegg, and then they don't give me answers. I have to submit things, and I have to get my dean to approve my submission search to get them to give me answers back. And then they tell me if I give them a test, they can keep the test questions from getting posted for 24 hours, but no longer than that. But if they have the ability to keep it from getting posted for 24 hours, they have the ability to not let my stuff go on their site, and they choose not to. So I despise the people at Chegg. But anyway, so if you're not sure, ask. I will show you how you can cite sources, because half of these things I'm going to be copying off the book, right? Because he's already solved this particular data structure thing. I don't need to go reinvent the wheel, so I'll show you. This is how you cite a source. Just leave a comment in, no problem here. Something like, hey, I need to go find a prime number or figure out how the number is prime. You don't need to do that yourself. You go Google that, find the little function that tells you what number is prime, paste it in, cite your source, we're cool, right? You can't go Google a solution to the entire project, paste it in like an English paper, right? You're not going to turn in 5 pages of a single quote and say, here's my English paper, here's my source, cite it. It doesn't work like that, right? It doesn't work like that for coding either. So if you find something, great, but you're putting it in with your original work, that sort of thing. Okay. That's it for the academic integrity policy. There's a syllabus quiz that I'll talk about in a little bit where you agree to this policy. You said you understand it, you've read it, and if you have questions, you'll ask me. That's my little CYA. So when I have to turn in all the paperwork to the dean, I say, yes, they agreed to this policy, they understood what it was. In this academic code of conduct committee process, there is a branch that says my sanction gets overturned. I've never had that happen in 10 years. Right? It's just, it hasn't happened. So please don't make me do the paperwork. It upsets me. Sorry, I'm getting all worked up right now. I had one semester, 8 people failed for cheating on the final exam. It was ridiculous. Like, it was open book, open notes. All they had to do was cite their source, and they just copy pasted. And they didn't cite their source. And they all cited the exact same source. That's why it was obvious, too. All 8 of them. That was really depressing. A fun story, though, they actually had to retake it as an independent study course, and they paid me to be their teacher for it. The university did, because it was a prereq for another class they had to take, and all the other sections were already full of it already. It was nonsense, just complete nonsense. So anyway, late projects and homework and assignments. I don't take things late, particularly around the projects. So projects will be due before class starts, or like the time of class starting at 3:30, because I'm going to go over the solution to it in class. So I've found there tends to be, people have told me it's valuable. If you think it's a waste of your time, please tell me otherwise. I'm happy to change my practices, but most people say having me solve the project and go over, okay, this is how I would solve it here, has been useful, because everyone's going to approach it differently, and that's okay. That's part of the fun. Crow CYA is cover your ass. It's like having the right documentation so you don't get sued. Yes, when I said that's my CYA, sorry. So that's my policy, and you agree to it. All the other things for attendance, academic integrity, the generic one, counseling, disability services, safety and harassment, sexual violence, bias, discrimination are all available in Canvas under the course policy section. They should be the same for every class here. Okay? Oh. All right, that was a lot of talking, sorry. Any questions so far? We doing okay? And that's the tentative plan for the course. Should be a fun semester. All right, cool. So we'll spend a little bit more time. I don't want to keep you too long because we also have Thursday as well. I want to show you some other GitHub workflows here. So far all we've done is we've used the Classroom GitHub link to create a repository. So I'm going to go through and I'm going to make a new repository. So if you were to make a repository for yourself, which you're welcome to do, and a lot of people tend to make these, and this is kind of their like public profile. Their, I don't know, you can turn this in on your, like, put a line on your resume. Here's my GitHub profile. This is all the things I've done. You can feature certain things, and it's kind of cool. I don't necessarily think it's like the most important thing on a resume, but it's a nice place to say, hey, here's some work that I've done. So if there are any interesting projects after they're due, you're welcome to copy them over to a public repository if you'd like. That's perfectly fine, because I'll be posting the answers on my public repository. But please use the private ones up until the due date. Does that seem okay? All right, so you go to repositories, and you say new repository. You give it a name. So these repository names have to be unique for you, because they are attached to your profile. So that should be easy. And I name them really easily. So 2001, winter 2022. That's our course repository. Now, I'm going to set mine to public. So you're allowed unlimited private repositories with GitHub once you have an account. The only thing they'd limit you to is how many people have access to them. So if it's a private repository, initially only you have access. You can add access to other people, and that's part of that GitHub Classroom flow. It automatically adds me and you for access, which is fantastic. Makes my life easy. But public ones are just available online. Anyone can go see the code that's in the or really anything you put in the repository. They're made for code, but you can jam all sorts of files in Git. I'm going to add a README file. The README just gives you a nice little, it's a markdown format syntax. So you can, for a repository, put a little page, hey, this is what I'm about. Lots of pages have some really cool readmes, like the .NET ones do. Microsoft .NET Core, I think. I can't spell. That might be it. Hang on. Core repo. Let me just Google it. Oh, it's .NET account, not Microsoft account. So this is Microsoft's open sourced .NET Core code as they're trying to push more for open source stuff. It's really cool. Get all this cool history, but this is their README. Like this README file just has all sorts of cool stuff and links and about it, and so you can do all sorts of fun things here. Go for it. Ours, I don't really care what you put in there. I don't even bother doing much for the course either. But I have one there if you want one. The Git Ignore File is very important. This one says don't add certain types of files to the GitHub repository. The idea with this, and again, it's not as applicable to Python, but other languages that are compiled languages, you'll take your human readable code and you'll compile it into an executable or some Java bytecode, some intermediate language there that gets read by that runtime environment. If you can build it, you don't need to commit it, because every time you change the code, that's going to change too. It's just like extra churn, extra stuff changing, when you can just download the code and build it yourself. So like a release of code is stored separately from the actual source code itself. So we don't need to add it into our tool here. And they have all sorts of cool templates. So like for any given language, essentially you can go have it pre-built. Let's ignore these sorts of things here. So we can go find Python here. We'll take their, and I'm going to add a license. So anything that's public, you should add some sort of license to it. Even if it just says, hey, all rights reserved. You're just showing it. You're not going to let anyone use it, or at least won't allow people to license it officially. If it's public, people may or may not grab it anyway, but at least you've released that license there, and you can go after them if you need to. I'm a fan of the MIT license. It's just an open, easy to use, free access for everything. Just attribute your source essentially. And the things I do in class, it's nothing novel, so I don't care. It just makes it nice and easy. So I make the repository. So now this is going to be my location for all the things we do in class. All the code examples will go here. I don't add Python files to Canvas. You don't have to download Python files. We use a tool that's made for hosting code for you to go look at the code. It works out pretty well. So like if you wanted to see what's in the license here, this MIT license, commercial use, modification, distribution, private use, no liability, no warranty, that sort of thing is nice. Like, I'm not responsible for what happens if you run this code. That's a nice thing to have in here, just if you're putting out public code, but that sort of thing. It says copyright me, sure. The README file, again, sure. The Git Ignore file. There's not a whole lot in Python that we need to ignore. I mean, there's some decent numbers of things, but not too big of a deal here. So it just ignores anything that matches these. Oh, excuse me. Yeah, a bunch of packages, tools like that. Yeah, I don't even know what half of these ones are. But they have a nice little note here. No logs, no unit tests. Cool. That'll do. So now it's empty aside from those. So we've started it, we've initialized it, it's empty. I'm going to go open it with GitHub Desktop and clone it. So anyone can make a clone of this repository because it's public. You guys could clone the repository if you so care to. What you don't have access to do is commit changes to it. So you can pull changes down to your local machine. If you make changes, you can't push them back up because your account doesn't have permissions, right? You don't have access to the repository to make changes. Generally, I tell people to just copy paste instead of trying to keep things in sync and make sure you can keep on pulling changes down. It's probably easier to just go to the website, click the file, and copy paste it. But whatever you prefer. Not a big deal one way or the other. Sorry, I got chat on the other monitor here, and I'm bad at watching it here. At home, I've got the two screens side by side. Oh, no, actually, no, it's up and down. I moved it, but that's okay. Now I've got the repository, right? I can go show and explorer. I can see the files here. So the next thing we're going to look at, this a little bit more advanced Git workflow, is this idea of branches. The idea with a branch is that we have a separate place to track changes that aren't affecting the current main branch. There's a couple different philosophies when it comes to software engineering. Most people seem to agree that your main branch is your latest and greatest code that works. So anything in main should be working code, essentially. It's like finished product. It's been reviewed, whatever your peer review process is. It's all been looked at. it works. It's good. So a branch lets you do work isolated from that so you don't break anything. You don't screw anything up. So you can go to this branch here. We can say, hey, I want a new branch. And what's my new branch called? We'll call this, I don't know, example here. So I'm going to make a branch called example. Now, behind the scenes, Git will track everything that happens in this folder now in the example branch. Anything I commit here won't show on the main branch. So if I make changes to a file that exists and I want to go play with it, I want to, the organization says, okay, we now need to do this extra thing here with our current process, our current program. We need to go change it. I can't change it in main because it'll break, right? I need to make sure it's done and tested and approved and all that process outside of that. So now I can go and make my project. Let me fire up Pycharm here. And by fire up Pycharm, I mean click start and wait a minute. We're getting there slowly. So it's not the fastest tool, unfortunately. Okay, that wasn't so bad. So I'm going to start a new project. Maybe. Here we go. And let's put this inside of my GitHub folder. So make sure you don't put it outside of that repository folder. If you want it to be tracked by Git, it has to be inside the correct folder for that repository. So for Lab 0, it goes in the Lab 0 folder. For Lab 1, the Lab 1 folder. For Project 0, Project 1, Project 2, inside of each of those folders. There it goes. So GitHub. Here's my new CIS 2001 Winter 2022. There it is. I can't see. In this environment, things are a little bit funky. I have a virtual environment I set up here. So if you make a new virtual environment every time, it's essentially copying everything Python for every project. It just takes an extra 5, 10, 15, 20 seconds. It's not going to hurt anything, but it's work 20 seconds that you don't need to spend. So if you have an existing interpreter, just use that one, and life is good. It'll save you a couple seconds there. I like when it makes the main PY for me. When you use the GitHub Classroom workflow, there's already a main.py file. So it doesn't matter if you have that or not. For a brand new repository, there were no Python files in it. Right? The only things we had in here were the Git Ignore, a license, and a README. So I wanted to make one for me. So we'll create it here. Create from existing sources. Do it in this window. You can have multiple Pycharms open at a time if you want. I usually just use one. And you know what? I didn't put it inside of another folder. I did a bad thing. Let me do that one more time. I want a folder inside of here. That'll help me keep this a little bit more organized. So GitHub. So for my class repository, because I'm only using one, it'll make life a little easier for you guys to find stuff. I'm going to have, this is week 1. So I'll put everything in a week 1 folder for week 1, week 2 for week 2, or maybe by name. I don't know. I've not sold on a given naming convention, so I'll try that one more time. So if I put it inside of week 1, it ought to be a little better here. Okay. Now I have a week 1 folder, so I don't see that main repository folder. I'm happy. And my main PY file. So I can delete all the stuff that's in here already. I don't need any of that. So say our first task was to get some numbers and add them together. I don't know. It's not a very interesting thing. So we'll have a value A is an integer conversion of an input of the first number, and a value B is an int of an input of the second number. And then we're just going to print, I don't know, let's do value B plus value A. Why not? Sure, we'll just print out the results. We'll add it together. Not an interesting program, but we'll have something here. And maybe I can spell second. There we go. Let's right click and run. Make sure it does what we're supposed to do. So how about 4 plus 2 gives me 6. Okay, life is good. I've got something going here. I'm going to make a commit. And actually, I don't need any of this stuff, actually. So this was from when I initially made the project, the very first time. I'm going to get rid of those, so I'm going to say discard the changes. You want to be a little careful if you're discarding things, because it will undo. It reverts it back to the previous snapshot. And if it's a new file, reverting back means it deletes it. But I don't want any of those around. I want just the week 1 stuff. I don't want any clutter. Come on. Yes, discard. There we go. Okay. Now here, so week one, again, all these .idea files, that's fine. That's for Pycharm. Just leave all these files alone. They'll do whatever they want to do. But we care about the main py file. Right? I see here's my integer. I print out the results. So here's first pass adds 2 values. I'll commit. And now right now my button is publish. So my local repository knows about this branch that I'm calling example. The GitHub repository central, the cloud repository, doesn't know because I did it on my local machine. So to get in sync, I have to publish the branch. It's essentially the same thing as push, but it's registering there's a branch out there. That's fine. Now I have a create pull request button. We don't need that one yet. We're not quite there yet. But so now the buttons look a little bit different if you're on a branch. We're not going to do a whole lot of this for the individual projects. When you're working on the group project, this is a good workflow to have. It'll help you isolate changes so you don't blow away your partner's work. But I want to go about it here. So the website even tells me, hey, there's an example branch. Do I want to compare and pull request? The idea with the pull request is saying, hey, I want to take something from another branch and pull it back into main, or really any other branch. But generally our workflow is we pull it back into main. So once you have a completed unit of work done in that pull request, you have working code, you can go through the review process, and then you can pull it into the main branch or merge it into the main branch. And now I have new working code in main. So the goal is main should always work. But if you just want to go look at it, you can change the branch you're looking at with this little drop-down menu here. I can say, hey, I want to go find, view all branches. I want to find the example branch. You can click on the example branch. And in the example branch, I now see week one. So this little URL up here, it's no longer blob/main, it's tree/example. So we're looking at the branches in the tree. In some source control tools, you used to see this was called trunk. And you'd have a trunk and you'd branch off of trunk. I don't know. Names are funny like that. So we're looking at the tree here, and this is the example branch of that tree. So I can see all the changes here if I want. But if I go just back to the main repository, the regular view is the main branch. And I don't see any of that week one stuff. It's not there. Okay, so I've isolated that work. It's all separate. Now I haven't really changed anything in main, so I'm not at risk of anything breaking. I'm just adding brand new stuff. But once we commit and merge this, right? So we're going to do our compare and pull request. This will generate the pull request. It will add these in here. It's going to say, hey, I want to take everything from the example branch, push it into the main branch. Don't worry too much about the terminology. It takes lots of practice. Git's kind of a funny tool. We'll create the pull request. Now I have a pull request here. You guys automatically get the feedback pull request as part of the GitHub workflow. It saves you the time of doing this sort of thing, of making a branch, committing to that branch, and then opening a pull request. It's all just automatic, which is awesome. I'm a big fan of automatic stuff. But now I can go in here and I can see, and I can go to my files change list, and I'll see a bunch of files. Hey, this is all good. Someone else in my organization can do a peer review process, code review process, look at this, make sure I'm following my conventions, make sure I'm not doing anything stupid, give me feedback, at the line level, say, oh, hey, maybe you shouldn't call it value B, you should call it something else, whatever our conventions happen to be, right? And this sort of thing is awesome. I can't actually comment on my own pull request, which is a little sad. I thought that would work, but it's not right now. But that's okay. Once it's all done and ready, then behind the scenes, Git can merge the branch together, can merge the pull request. So you kind of get this visual idea of, the main is the center trunk, and you branch off, and then eventually you'll pull it back in, and you get rid of the branch. So it's not really how trees work, but the analogy only goes so far. So we'll branch off to isolate our work, then we can merge it back in. So the workflow for that's considered a feature branch. We want it to work on a given particular feature isolated from whatever else is happening. When that feature is complete, ready to go, we can bring it back in and have that feature now in our main branch of code. So I'll merge this, confirm the merge. It happens automatically behind the scenes. It's super cool. And you can even delete the branch when you're done, clean up afterwards. Again, different organizations have different workflows for how they do that. I just lost my screen. Yeah, that's super weird. It might be projecting still on Twitch. I don't know. I've got it showing in the other monitor. It hasn't gone black there yet. That's a little concerning. I might have broke it. Yeah, okay, the mouse isn't moving, but the screen's still there, so I might be getting a new computer soon. This one is pretty sad. Okay, so you can see my video on Twitch still. That's good, and my voice. So, well, it's 4:30. It's probably a good stopping point anyway. Why don't we call it a day then? And I'll figure out what's going on with my laptop. That was kind of sad. What if I just like unplug it? You gonna do anything? Maybe. It's making noises. I don't know if it's a good sign or a bad sign. All right. Well, we're about to end anyway. We'll pick it more up on Thursday. We'll talk more about those workflows, that sort of thing, and we'll go from there. We might start a little bit of review, maybe talk a little bit about stuff from Chapter 2, because I think we'll have a little bit of time extra on Thursday, so but we won't get too far ahead, don't worry. All right, so folks, take care. I can't actually end this now. I wonder if I got nothing. It's all dead. All right, folks online, take care. Everybody in person, good to see you. I'll see you on Thursday. The stream's probably going to hang around for like 30 seconds before it finally kills itself, so don't worry. I'll see you guys later. I'll see if I can just shut it down. Well, that was fun.
At least talking towards the end.